Today's lesson is about solving trig equations. We will talk about trig equation with a quadratic pattern. Let's go over the steps for solving trig equations. You have to check the pattern of the equation, choose the correct method to solve so that you can get the single trig equals a constant form. After that, get the reference angle and use this diagram get the solutions between 0 to 2 pi. Find the period. For sine and cosine, period will be 2 pi over b, tangent will be pi over b. Then find the general form according to this formula. Part 3. Solve for x on the domain 0 to 2 pi. As we know, whenever we have ax squared plus bx pattern, we know this is a quadratic pattern. For trig function, since we have cosine squared and also cosine, that means this is a quadratic pattern. Keywords will be equal to 0. For a, it's already equal to 0. So when we have ax squared plus bx, you use a common factor. When you have ax squared plus bx plus c pattern, you got to use a ninja x. Like this is a times c over a, here's b. To factor the quadratic pattern function. For a, we already got equal to 0. So we can just move on. Since this is a ax squared plus bx pattern, we need to do the common factor. We got cosine x is common factor. So we got 2 cosine x plus 1. We can set up cosine x equal to 0 and 2 cosine x plus 1 equal to 0. Because a times b equal to 0, we know we got the a equals 0 or b equals 0. For cosine x equal to 0, reference angle, that's pi over 2. So we got, this one is pi over 2. For 3 pi over 2, still 0. Therefore, you will get the x1 equals pi over 2, x2 equals 3 pi over 2. Let's talk about sine x, tangent x, and cosine x equal to 0. What's the solution? Find the reference angle. For sine x equal to 0, reference angle is 0. For tangent, this is still 0. For cosine, that's pi over 2. So we label here is 0. This is a pi. This is a pi over 2. Here's a 3 pi over 2. For sine x equal to 0, we got the reference angle equal 0. Then pi also the solution. Therefore, we got the 0 and a pi solution. Same to tangent x, it's a 0 pi. For cosine x equal to 0, reference angle is pi over 2. Then 3 pi over 2 will be the solution too. Therefore, we got the pi over 2 and 3 pi over 2. Try to remember this pattern. For trig function equal to 0, let's talk about the sine x equal to 1 and also sine x equals to -1. Also for cosine x equals to 1 and cosine x equal to -1. Still, we need a reference angle. This is a pi over 2. Reference angle is a pi over 2. For cosine, reference angle, that will be 0. Reference angle equal to 0. For sine x equals to 1, that's positive. So we got the pi over 2. That's all. Pi over 2. Because they go to the first two quadrants, that's only one solution, pi over 2. For sine x equals -1, that means these two quadrants. And reference angle is pi over 2. Therefore, we have 3 pi over 2. For cosine x equals to 1, this is a positive, which means the first and then the fourth quadrant. That's only 0 will be the solution. For cosine x equals -1, that's a negative. For cosine, it's this two quadrant. Reference angle is 0, that's only pi will be the solution. So when sine x or cosine x equals to maximum value, there's only one solution between 0 to 2 pi. Now let's go to 2 times cosine x plus 1 equal to 0. It's a linear pattern, that's why I isolate the cosine x. You will get -1 over 2 because -1 both sides and divided by 2. Reference angle, that is pi over 3. So we go to this diagram. For cosine x equals -1/2 is less than 0, means go to second and then the third quadrant. Therefore, we got 2 pi over 3 and 4 pi over 3. The angle for cosine, that's x. So I can write down x equals 2 pi over 3 and also x equals 4 pi over 3. Label x x3, x4. So for A, we have 4 solutions. Now let's go to B. For B, this is a quadratic pattern, therefore equal 0. We move sine x to the left side to make sure this A is positive. So we got 2 sine square x minus sine x. Remember, cross the river, change sign. Then we do common factor, the sine x. We got the 2 sine x minus 1 equal to 0. Set up sine x equal to 0 or 2 sine x minus 1 equal to 0. For sine x equal to 0, reference angle, that's 0. Therefore, we got 0 pi will be the solution. For 2 sine x minus 1 equal to 0, this is a linear pattern, so isolating. Add 1. So we divide by 2. You will get sine x equals 1 over 2. Reference angle, that's pi over 6. Since sine x equals pi over 2, that's positive. So we go to the first quadrant and the second quadrant. You will get pi over 6 and also 5 pi over 6. So we got x3. This is x. You have to equals this 2. So x3 equals pi over 6 and x4 equals 5 pi over 6. We check the pattern still quadratic pattern. Make sure that's equal to 0 form. This is a ax squared plus bx plus c pattern. Therefore, using ninja x, you will get 2 times negative 1 is negative 2. Here's 1 over 2 over 2. For negative 2, you will get the 1 times negative 2. Adding is a negative 1, but we're looking for positive 1. Therefore, we change the sign. We will write down negative 1, here's a 2. Reduce, you will get the 1 over 1. Then what's the variable? Variable will be cosine x. Therefore, I will write down cosine x and a cosine x. Because cosine x times cosine x, that's cosine square x. So we do bottom up, you will get the 2 cosine x minus 1. And cosine x plus 1 equal to 0. We can set up 2 cosine x minus 1 equal to 0, or cosine x plus 1 equal to 0. Still isolating because these two are linear pattern. Cosine x, you add 1 divided by 2, that's 1 over 2. Reference angle, that's pi over 3. Positive. We go to first and then the fourth quadrant for cosine, positive. So we got the pi over 3 and 5 pi over 3. Therefore, for this x, you will set up x1 equals pi over 3 and x2 equals 5 pi over 3. Then go to the cosine x plus 1 equal to 0. Isolate the cosine x on one side, you got the cosine x equal negative 1. That's only one solution. That's x equals to pi. Because your reference angle equals 0. For cosine negative, let's go to second and then the third. Reference angle is 0, only pi will be the solution. So we got the x3. In other words, we have 3 solutions for C. Let's go to E and F. It's still quadratic pattern. We need equal to 0. When you solve any trig equation, make sure you have the same angle. And also have the same trig. Remember this. Therefore, for E, angle both is x, is good. But the trig function, I have sine, square, and I have cosine. You have to change sine into cosine. Using this formula, we have sine square x plus cosine square x equal to 1. In other words, we got the sine square x equals 1 minus cosine square x. So we change sine square x into 1 minus cosine square x. That's the first step. Then you need to check which side you need to move. We got the 2 minus 2 cosine square x equals to 2 minus cosine x. This is a quadratic pattern. We need equal to 0. So where you move, is it move everything from left side to the right side or from right side to the left side? Check coefficient for cosine square x. We want that it's positive. That's why you move everything to the right side. You will get 0 on the left side. So we got -2 plus 2 cosine square x. Then plus 2 minus cosine x. Combine like terms. This is gone. Therefore, we got the 2 cosine square x minus cosine x. You have to use a common factor to factor this. We got the cosine x, 2 cosine x minus 1. This is equal to 0. Then we will set up cosine x equal to 0. And also 2 cosine x minus 1 equal to 0. For cosine x equal to 0, that's a reference angle pi over 2. So we got the x1 equals pi over 2 and x2 equals 3 pi over 2. Then we need to solve this part. Linear pattern, we got the cosine x plus 1 divided by 2. So you get the 1 over 2. Reference angle, that's the pi over 3. For cosine positive, that means the first quadrant and then the fourth quadrant. So we got the pi over 3, 5 pi over 3. Look at the angle, that's x. So we got x3 equals pi over 3, x4 equals 5 pi over 3. Now let's go to f. Still, we need the same trig function. Therefore, for sine square x, that's equal to 1 minus cosine square x. So we got the 2, 1 minus cosine square x plus 3 cosine x minus 3 equal to 0. Do distributive property, got the 2 minus 2 cosine square x plus 3 cosine x minus 3 equal to 0. Combine like terms, we got -2 cosine square x plus 3 cosine x minus 1 equal to 0. Make sure the a, that means the coefficient for cosine square x is positive. That's why I change sign. This is positive, negative, positive. I can get 2 cosine square x minus 3 cosine x plus 1 equal to 0. We have to use ninja x to do the factoring. So we got the 2 negative 3 over 2 over 2. For 2, I got the 1 times 2. Adding is 3, but we need -3. That's why we got the -1, -2. So you reduce, you get the -1 over 1. Then check for variable. This is a cosine x. And then cosine x. Bottom up, we got the cosine x minus 1 and a 2 cosine x minus 1 equal to 0. Therefore, we got the cosine x minus 1 equal to 0 or 2 cosine x minus 1 equal to 0. And we got the cosine x equal to 1. That means x1 equal to 0. For this part, cosine x equal to 1 over 2. Reference angle, that's pi over 3. Go to first and then the fourth quadrant. That will be pi over 3 and also 5 pi over 3. Therefore, for x2 equals pi over 3, x3 equals 5 pi over 3. Let's go to I. It's still quadratic pattern because we know the degree for x times y. That's 2. For sin x times cosine x, degree still 2. So we count as a quadratic pattern. Equal sign, that's the keywords. So I move everything to the left side. We get the square root of 3 cosine x sin x minus 2 sin x equal to 0. Then common factor will be sin x. You will get the square root of 3 cosine x minus 2 equal to 0. Therefore, you got the sin x equal to 0. And also, we set up square root of 3 cosine x minus 2 equal to 0. For sin x equal to 0, reference angle, that's 0. Therefore, we got 0, here's pi. x1 equals 0, x2 equals pi. For this equation, we know that's linear pattern, so you need to isolate the cosine x. I add 2 both sides. You will get square root of 3 cosine x equals 2. Then you will get the cosine x equals to 2 square root of 3. Since for cosine has to be between -1 and 1, but 2 over square root of 3, that's greater than 1. Therefore, here's no solution. Therefore, we only have 2 solutions for this equation. Let's go to some special case. If you have sin x equals negative cosine x, we divide by cosine x both sides. You will get tangent x equal to -1. Then go to reference angle equals pi over 4. Tangent and negative, let's go to second and fourth. When reference angle equals pi over 4, we got 3 pi over 4 for second quadrant and 7 pi over 4 for fourth quadrant. Angle for tangent, that's x, so we write down x1 equals 3 pi over 4, and also for x2 equals 7 pi over 4. Let's go to B. For B part, we got the sin x equals tangent x. For sin x equals tangent x, you need to change tangent x into sin x over cosine x. Then we do cross multiply. You will get sin x cosine x equals sin x. This is a quadratic pattern. That's why we get equal to 0. So move sin x to the left side. You will get the sin x cosine x minus sin x equal to 0. Common factor will be sin x. So we got the cosine x minus 1 equal to 0. We will set up sin x equal to 0 and a cosine x minus 1 equal to 0. For sin x equal to 0, reference angle, that's 0. So you will get 0, here's pi. Therefore, you will get the x1 equals 0, x2 equals pi. For cosine x minus 1, you need to move -1 to the right side. You got the cosine x equal to 1. That's x will be 0. Only one solution when sine and cosine equals to maximum value or minimum value.